Hello and welcome back. Today we're going to learn about what are called W wings. I'm not sure why these things are called W wings because their shape does not really resemble a W. Maybe it's because they used up the letters XYZ on the last two types of wings. I don't know. You have to have a vivid imagination to see these as W's. In any event, this is one very cool and very powerful technique. The trick is being able to identify them because they are not always obvious and you have to really search for them. And they can take on some peculiar shapes that are not immediately intuitive. But don't worry, I will show you what to look for and give you some handy tips on how to find them. So let's go over to the puzzle board and see what a W wing looks like. If you remember from video number 23, an XY wing is composed of 3 bi-value cells, and the 6 candidates in those 3 cells are connected by an open-ended AIC of exactly 5 links, like this. Strong, weak, strong, weak, strong. This ensures that at least one of the endpoints must be true, which further allows us to eliminate any same-digit candidate that can see both ends of the chain. So here in this diagram, either the blue 9 or the yellow 9 must be true, so all the red-colored 9s would be false. Simple, right? A W wing is pretty much the same thing, except that the pivot is a conjugate pair instead of a bi-value cell, and the 2 pincer cells will always be identical bi-value cells, like this. Strong, weak, strong, weak, strong. The middle link of an XY wing is the strong link between the 2 candidates in the pivot cell, which is a bi-value cell, here being R3C5. In a W wing, the middle link is the strong link between the 2 candidates of the conjugate pair, here in row 3, so the construction is basically the same. But a W wing involves only 2 candidates that we will call A and B. And there will be 4 instances of candidate A and 2 instances of candidate B. The pivot will be a conjugate pair that we will call A1 and A2. And the 2 pincers will be AB1 and AB2. And of course, you can switch the 1s and the 2s if you want. They are interchangeable. Either of those 7s in row 3 could be A1 or A2. I am just using those names so you will know which one I am talking about. The 2 candidate Bs will always be the endpoints of our chain, and thus they will be the ones that produce the candidate eliminations, if there are any to be made. The chain will always start and end with our candidate B. So here is a typical W wing. Of course, candidate A and candidate B can be any 2 random candidates, but here in this diagram, candidate A is 7 and candidate B is 6. So any other candidate 6 that can see both ends of the chain will be false. In this case, the 2 red-colored 6s in R1C1 and R5C9. The conjugate pair can be in a row like this, or it can be in a column like this, or it can be in a block like this. And the logic is the same regardless. One of the 2 endpoint candidate Bs must be true. Now please realize that in real puzzles, candidates A1 and A2 in the conjugate pair will not be naked singles like you see here. There will, of course, be other candidates in those cells, as well as in the house containing them. These hand-drawn diagrams are for demonstration purposes only. I am isolating the candidates to make them easier for you to see. Capiche? Notice that the 2 bi-value cells will either be in different chutes, like you see here, or they can be in the same chute, like you see here. As with all the other techniques we have learned that are based on AICs, When the two endpoints lie in two different chutes, then there can only be two possible eliminations. Like here, this 6 would be false, and this 6 would be false because they can see both ends of the chain. And in this diagram, these two 8s would be false because they can see the two endpoints of the chain. And in this diagram, these two 4s would be false because they can see the two endpoints of the chain. And when the endpoints lie in the same chute, then there can be up to 6 eliminations. Like here in this diagram, the two candidate Bs are candidate 1, and they lie in the same chute. So there are 6 cells that can see both of those endpoints, and they would be here. If there was a 1 in any one of those 6 cells, they would be false. And don't forget, the conjugate pair does not have to be in the same chute with the two bi-value cells in the event that the two bi-value cells are in the same chute. Like here in this diagram, the two bi-value cells are in the same chute, but the conjugate pair is in a different chute. But here, because 9 is our candidate B, these 3 9s up here would be false, and these 3 9s down here would be false. Okay? And then lastly, when the conjugate pair is on a diagonal and the two bi-value cells are in the same chute, it would look like this. And since candidate 2 is our candidate B, these 3 candidate 2s would be false, and these 3 candidate 2s would also be false. And if the two bi-value cells are in the same house, like this, they will simply be a naked pair, and you will not need a W wing. The naked pair will be more powerful all by itself, as it will eliminate all other instances of both A and B in that house. Like it would eliminate this 3 or this 8, for instance, or this 8 and this 3, or this 8 and this 3. Those would all be false because of that naked pair in column 5. And this configuration would also be an X-wing on the candidate of the conjugate pair, which here is 8. And that means here in this diagram, you could eliminate all the 8s from row 3 and row 7. Like you could eliminate that 8, or 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 that 8. Any 8 in row 3 or row 7 outside those colored cells would be false because this would be an X-wing. The two candidate 8s in column 3 are a conjugate pair, and the two 8s in column 5 are part of that naked pair. So that would be an X-wing on 8, and you could eliminate all those red-colored 8s. Got it? Good. So here are the basic rules for a W wing. There will be 4 cells connected by an AIC of 5 links. The pivot will be a conjugate pair composed of A1 and A2. The two pincers will be identical bi-value cells, AB1 and AB2, with one in the same house as A1 and the other in the same house as A2. The two pincer cells will not be in the same house. One of the two candidate Bs must be true. Therefore, any other same-digit candidate that can see both candidate Bs, i.e. B1 and B2, can be eliminated as false. Now, understanding the logic of W wings is simple, but finding these things in puzzles can be tricky. So let's take a look at some real examples and some real puzzles so that we can familiarize ourselves with the many possible configurations and oftentimes odd shapes that these things can take. All right, here in this puzzle in column 6, we've got a conjugate pair on candidate 1, and then here are our two pincer cells. And that makes a W wing. So here's our chain. It begins on 4, and there's a strong link to that 1, a weak link to that 1, a strong link to that 1, a weak link to that 1, and finally a strong link to that 4. So that means any candidate 4 that can see the blue 4 and the yellow 4, which are the endpoints of the chain, will be false. And in this puzzle, there's only one, and it's right here. Okay? Now these other 4s, they do not see both the endpoints. So those, you can't do anything about those. But the red 4 in row 4, column 1 is false, and you can eliminate it just like that. All right, let's go to the next one. All right, here in this puzzle, we've got an interesting configuration. We have a conjugate pair in row 9 on these two 1s. Okay, and then here's one pincer of 1 and 9, and here's another pincer of 1 and 9. So let's draw the chain. Candidate 9 will be candidate B, and that's a strong link. And then that's a weak link, a strong link, a weak link, and a strong link. So one of those two endpoint candidate 9s must be true, which means any 9 that can see both the blue and the yellow 9 will be false, and here there are only 2. These two 9s can see both of those 9s, and therefore they are false. All right, let's go to the next one. All right, here in this puzzle, our conjugate pair is on a diagonal this time on these two candidate 9s in block 6. Now this is one of those that has an unusual shape, and we've got one pincer here and one pincer here. Now this almost looks like a two-string kite, but it cannot work as a two-string kite because there are more than 2 9s in row 5. So this is a W wing. So let's mark the chain and then we'll draw the chain. The candidate B's are the candidate 2s, so we've got a strong link, and then a weak link, and then a strong link, and then a weak link, and a strong link. So any candidate 2 that can see both of those endpoint 2s will be false, and here there's only one. Now remember, when these pincers are in different chutes like they are here, there can only be 2 possible eliminations. The other elimination cell here would be row 5, column 8, but there is no candidate 2 in there. So we've only got one candidate 2 to eliminate, and it's right there. So let's put it back in, and now let's actually draw the chain this time. We've got strong, weak, strong, weak, strong. Does everybody see that? Now remember that when you are visualizing the chain, you can start on either end and the logic is the same. So there is really no direction to this, and that's why I'm using lines instead of arrows. But you don't have to visualize the chain each time. Just familiarize yourself with this pattern, and now because you know that this technique is going to work, you don't have to think about the chain anymore. You can just see this configuration and eliminate that red 2. Okay, let's go to the next one. All right, in this puzzle, our conjugate pair is in row 9 on candidate 4. Okay, and then the two pincers are this 4-3 and 4-3. So 3 is our candidate B, and we can start on either one. So let's start on this one, and we've got a strong link, and then a weak link, a strong link in the conjugate pair, and then a weak link up to this bi-value cell, and finally a strong link to that 3. So that means any other candidate 3 that can see the blue 3 and the yellow 3 will be false, and in this puzzle there are only 2. There's one here, and there's one here. Now these two pincers are in the same chute. They're in the same top horizontal chute, which means there can be up to 6 eliminations. But in this puzzle there are only 2, one here and one here. All right, let's move on to the next one. All right, we've got to start moving a little faster now because we have a lot of examples to go through. So here in column 6, we have a conjugate pair on candidate 1. Okay? Now the two pincer cells are 1 and 6 and 1 and 6. Now you've got to have a good eye to see these because this 1 and 6 up here in row 5 sees this one in row 4, and this 1, 6 in row 9 sees this one in row 7. And believe me, this configuration is not easy to see when you don't have the cells colored like this. So let's mark the chain. It starts on 6. We have a strong link to the 1, a weak link to that one, a strong link to that one, a weak link to that one, and finally a strong link to that 6. So candidate 6 is our candidate B, and the blue 6 and the yellow 6 are B1 and B2. So any other candidate 6 that can see both of those 6s will be false. And in this puzzle, it looks like there are 3. There's one here, there's one here, and one here. Those 3 red 6s can see both of the endpoints of the chain. All right, next one. All right, here our conjugate pair is in row 4 on candidate 4. Those are the only 2 4s in row 4. So there is a conjugate pair and a strong link between them. And then we have a pincer up here and a pincer up here on 1 and 4 and 1 and 4. So candidate 1 is our candidate B, and that means any candidate 1 that can see both of those 1s will be false. So let's mark the chain. Let's start on this one. We've got a strong link, and then a weak link, a strong link, a weak link, and a strong link. So because those two pincers are in the same chute, there can be up to 6 eliminations, but here there are only 2. There's one here and one there. Those are the only 2 1s that see both of those endpoints, and they can be eliminated as false. All right, let's go to the next one. All right, this time our conjugate pair is on candidate 2 here in block 4. Those are the only two 2s in block 4, and they're on a diagonal. And our two pincer cells are here and here of 8, 2, and 8, 2. So that means candidate 8 is our candidate B. So let's start down here. This time we've got strong, weak, strong, weak, strong. So any other candidate 8 that can see both of those endpoint 8s will be false, and in this puzzle there's only one, and it's right there. That candidate 8 is false. All right, next. Okay, here in this puzzle our conjugate pair is in row 5 on candidate 9. Those are the only two 9s in row 5. So we've got A1 and A2. And then we've got AB1 and AB2. Those are our two pincer cells of 8 and 9 and 8 and 9. So 8 is our candidate B, and we've got strong, weak, strong, weak, strong. So one of those 8s must be true, which means any other 8 that can see both of those 8s will be false. And in this puzzle there are 3 of them. There's one here, and one here. Those 3 red-colored 8s can see both of the endpoints of the chain, and therefore they are false and can be eliminated. All right, next one. All right, this time our conjugate pair is in column 8 on candidate 1, and our two pincers are here, 1 and 9 and 1 and 9. Now sometimes the conjugate pair is going to be in the same chute with the pincers, and sometimes it isn't. In this case, the conjugate pair is not in the same chute with the pincer cells, but it works just the same. So candidate 9 is our candidate B, and here's our chain. Strong, weak, strong, weak, strong. So any other candidate 9 that can see both of those 9s will be false, and in this puzzle there are 3 of them. There's one here, and one here. Those 3 9s are false. All right, next one. Okay, here in this puzzle our conjugate pair is on a diagonal up here in block 1 on candidate 8. Those are the only two 8s in block 1. We've got one pincer down here of 8 and 9, and another pincer over here of 8 and 9. And this time the pincers are in different chutes, which means there can only be 2 places to make a candidate elimination. In this puzzle there's only one candidate 9 to be eliminated, and it's right there. However, if there happened to be a 9 in that cell, that could also be eliminated, but as you see there's a 4 placed in there. So there's only one elimination in this puzzle, and it's right there. You can eliminate that candidate 9. All right, next one. All right, this time the conjugate pair is in the same chute with the pincers, and the conjugate pair is on candidate 5 here in column 6. The two pincers are 7, 5, and 7, 5. So candidate 7 is our candidate B, and we start here, and that's a strong link, a weak link, a strong link, a weak link, and a strong link. So any other candidate 7 that can see both of those 7s will be false, and again we have 3 eliminations. 1, 2, 3. All right, next one. Okay, this time our conjugate pair is in row 8 on candidate 9. There's A1 and A2, and here's AB1 and here's AB2. Those 5, 9, 5, 9 up there in that top horizontal chute. So that means candidate 5 is candidate B. This is AB1 and AB2. So we're going to start here. That's a strong link, a weak link, a strong link, a weak link, and a strong link. So either the blue 5 or the yellow 5 is true, which means any other candidate 5 that can see both of them will be false, and in this puzzle there are 3. 1, 2, 3. All those candidate 5s are false. All right, next one. Now when you are trying to find these W wings, you can look for 2 identical bi-value cells anywhere in the puzzle and then see if you can find a conjugate pair by which to link them up. But quite often, about 2/3 of the way through, as I'm sure you will notice, there will usually be many sets of matching bi-value cells all over the place, but it will be a rare occurrence when you are able to find a suitable conjugate pair with which to construct a W wing. Like for instance here, there's a 5, 6 and a 5, 6, but now there's no conjugate pair to hook those up, okay? And likewise, there's a 3, 9 and a 3, 9, and there is also no conjugate pair to hook those up. But there's yet another point that I want to make. If you see that 3, 9 and that 3, 9, before you go looking for a conjugate pair, you will notice that there are no 3s or 9s in these elimination cells. So even if you found a conjugate pair, there would be nothing to eliminate. And the same thing goes for the 5 and 6 I showed you a minute ago. There is no conjugate pair to hook those up, but also there is no candidate 5 or 6 in that cell, and there's no candidate 5 or 6 in that cell either. So this would be a waste of time, all right? So if you can, make sure there's an elimination to be made before you spend the time to put this together. All right, let's take a look at this puzzle. Our conjugate pair here is on candidate 7 here in row 6. There's A1 and A2. And then we've got 7-1 and 7-1. Those are our two pincer cells, AB1 and AB2. So now candidate 1 is our candidate B, and that means any other candidate 1 that can see both of those 1s will be false, and there's one here and there's one here. Both of those are false. All right, let's go to the next one. All right, here our conjugate pair is on candidate 3 in column 5. And the two pincers are 3-6 and 3-6, and they are not in the same chute, so there can only be two possible eliminations. And one of them is right here, so that 6 is false, but as you can see, there is no 6 in that cell, so there's nothing to be done there. All right, let's move on to the next one. So instead of starting out by looking for two bi-value cells, the alternative method would be to start by looking for conjugate pairs first, and then look for two identical bi-value cells, each containing candidate A, to make the W wing. I think that your time might be better spent doing it this way. But you should do it whichever way makes the most sense for you, or whichever way is easiest for you. Or maybe you will find your own way of doing it, which would be great. If you think of something clever, please let me know. I think that you will find that there are generally fewer conjugate pairs than there are bi-value cells, so it seems more efficient to me to locate the conjugate pair first, because without the connecting conjugate pair, there is no W wing. All right, let's take a look at this example right here. We've got a conjugate pair here in row 8 on candidate 1, okay? And then we have two pincer cells of 1-9 and 1-9. Now this conjugate pair is like in between them. It's really hard to see, but the more you practice looking for these, the better you will get at it. All right, so we know that our candidate 9 is our candidate B. So here's our chain: strong, weak, strong, weak, strong. So any candidate 9 that can see both of those 9s will be false, and there are 3 of them. There's one here, there's one here, and one here. They are all false. All right, let's do a couple more. All right, here our conjugate pair is on candidate 5 and row 7. That's A1 and A2. The two pincers are 45 and 45. So that means candidate 4 is our candidate B, and any candidate 4 that can see both of those 4s will be false. And in this puzzle, there's 1, 2, 3 of them. They are all false. All right, let's do one more. All right, once again, we've got our conjugate pair sandwiched in between the pincers like this. There's the two pincers, 6-9 and 6-9. The conjugate pair is on the two 6s in row 8. So there's your W wing, and candidate 9 is our candidate B. So that means any candidate 9 that can see both of those 9s will be false. And here there are 4. 1, 2, 3, 4. Now remember, when the pincers are in the same chute like they are here in this lower horizontal chute, there can be up to 6 eliminations, but here there's a 2 and a 5 already placed in these two cells where there might have been another 9 to eliminate. All right, that's going to do it for today, so let's go back outside and finish up. Thanks for watching. So there you have it. Those are W wings. They are very powerful, and they will start to pop up occasionally about midway through a puzzle, and even more so as you are entering the final stages. They are not as easy to spot as an XY wing, but with a little practice, I'm sure you will begin to see them on a regular basis. And believe me, it will be well worth your while to find them, as they can provide up to 6 eliminations at once. In the next video, video number 26, we are going to learn the basics of a configuration called two-sector disjoint subsets. Sounds kind of scary, huh? It's a little obtuse, I admit, but I promise that I will explain it in such a way that you will easily understand it. It is a method of splitting up a quadruplet or a quintuplet into two different houses instead of just one house, which will then allow us to make partial eliminations in both houses. It's a very clever technique, and it will be a lot of fun to learn, I assure you, and I hope to see you then. In the meantime, be well and be happy.